Very good morning, everyone. So I'm Woei from Nanyang Poly, and here is my partner, Simon. Both of us is from Nanyang Poly, and today we are here to share with you a different approach, which is a data-centric approach for cybersecurity to analyze the cybersecurity behavior for manufacturing sector. So first, this is a rough agenda for our sharing today. I will go through a very brief introduction on manufacturing sector and then type of data that we are dealing with for manufacturing shop floor, followed by current practice or limitation in manufacturing shop floor. And there are two so-called research outcome, which is our damage index and vulnerability index that we are going to share to you today. And last but not least, we will do a simple conclusion about our sharing. So why are we actually choose manufacturing as our research focus? First of all, I'm from a manufacturing background, and Simon is from a cybersecurity background. Hence, we actually come together and we discover this almost consecutively about 3 to 5 years. Manufacturing sector tends to be one of the top 5 industry that experience most cybersecurity hacking. So, before I proceed to tell you more detail our outcome, I think I would need to share with you more about the working environment, or what kind of manufacturing environment are we talking about and what kind of data are we dealing with. So typically, this is a manufacturing shop floor that I'm working in and our research focusing on. So for this kind of shop floor, it's a production shop floor with different type of machine. And what kind of machine are we looking at is CNC machine, computer numerical control machine. And what is this machine doing is mainly we load a raw material, it be it a block of metal, a block of plastic into a machine, and then we send some code to the machine, and the cutter will move according to our codes to produce some end product. So the most familiar one will be our engine block, our aeroplane impeller, or some metal structure. And all this kind of product actually is come out from this kind of machine, CNC machine. There are different kind of CNC machine around. So for this kind of shop floor, the data network that we are looking at is, it starts from CAD/CAM workstation. So what is this CAD/CAM workstation doing? We will have a batch, a group of designer, programmer, that they use this station to do design. They design their product. After they design, they do some process to generate a code which is able to send to their machine. Before that, all this data will be pushed to a data server. So as an operator, they go to the machine, they pull out this programming code from a data server, load it to the machine, and then start to execute this code. So during the execution, the cutter, which is the one that remove material, will follow this piece of code and remove the excess material to get the final shape. So the line that connect these different entities is actually showing us data can flow across different workstations and store in a data server. And as an operator, they pull the data from the data server onto their machine. So, and all this data that we are talking about is a manufacturing data. It's totally different from different sector. Like for IT sector, we are looking at different data, and for banking sector, we are looking about customer privacy, customer particular or customer data, transaction data. But for this environment, particularly, we are looking at manufacturing data. And what kind of manufacturing data we can discover from this kind of environment? Broadly, there's only 3 types of data. It's a product data, process data, and control data. So for product data, it's the data that govern the product. So let's say today I'm doing fabricating an engine block. So the product data will be the CAD model. And then process data is the data that we need to produce or fabricate this particular part. And the control data, particularly, is the data embedded on each of the machine. So here, I actually illustrate an example here. So a product data, commonly in any of the manufacturing shop floor, we are dealing with CAD model. So CAD model is a 3D file. Inside is all XYZ coordinates that able to give us the profile or the shape of the product. And then process data. So before we move about to produce the part, based on the CAD model, which is the product data, we need to generate a series of code to control our cutter to remove the material to produce the parts. And once we get that done, we will send that particular process data to a machine. And it comes to the control data, which is on the PLC or on the SCADA, that actually digests this process data and control the machine to move to a particular position. So these three types of data is mainly our research focus, the manufacturing data. So move forward now. For current practice in manufacturing industry, what we are doing now is we're still using a IP asset-centric approach, which is we still look at which computer worth the most, and we try to protect the computer. Let's say we got a 16-core PC, or we got a data server, the most expensive one, we try to protect them. But is this really work for manufacturing sector? In fact, it's not, for someone that try to hack a manufacturing sector, they are not trying to kill this particular data server or this particular workstation. What they are interested at is the manufacturing data. So today, if someone hacked my system, they are trying to take away my CAD model and go back and they try to refabricate a clone version of the product. And they try to make money out from there. So if manufacturing enterprises, they still focus on protect a computer, then that approach is not a right approach for manufacturing sector. Hence, we actually propose a different approach, which is a data-driven approach. So this data-driven approach is trying to analyze the data that we store in different entities in our manufacturing sector. So let's say if we run analysis, we need to see what is the value of the data that's stored in a particular workstation. And what we need from there is we need to estimate two things. One is the damage. If today I experience a hacking on my workstation, how much value or asset am I losing if this person grabbed my manufacturing data? And also, I need to assess my machine, the vulnerability of each of the entities in my manufacturing shop floor in order to protect them. And we actually come about to propose two index. One is damage index and one is vulnerability index. With these two index, then I know what kind of damage am I going to experience if there's a hacking, and which entity should I protect, and protect up to what level, instead of just blindly follow the IT-centric approach that use different kind of antivirus software installed to the computer and protect it. Okay, so the following slide, we will share with you our data-driven approach. Now on your mic.
Hi. So thanks, Amy, for the good introduction. By the way, both of us teach. So, right, so sometimes it's refreshing to see you guys not falling asleep because we expect our students to fall asleep after 10 minutes. Yeah. All right. Okay. So now we have gone through an introduction that we are targeting at the manufacturing industry. So folks at the manufacturing industries are not IT folks. They are not. So one common question that we have, or struggle we have is, hey, boss, I need $1 million. I need $2 million or X dollars to protect my asset. Where? Where should we protect them? Why should I give you $1 million? Right. So overall, this model that is data-centric helps to answer those questions. We would like to, as Ingrid has shared, we're going to look at two indexes. One, the damage. In other words, if there is a certain entity, a machine, or a certain component that goes down, what loss are you looking at? Well, that entity can have very high loss, but what is the vulnerability associated with the same entity? Right? So there are two dimensions here, the damage and the vulnerability. So for the damage index, we're going to break it down into three main components: explicit, implicit, and the decipher. Right. So for each entity, we're going to suggest that there are three components as we shared: the decipher, explicit, and implicit. And we're going to apply that for the three types of data that we've broken down with, that we've shared earlier. Okay, so the very IT-centric way of doing things is like, hey, look, my PDF file, my whatever emails, all these are what we call the product data. So we're very familiar with that. But in the manufacturing industry, we have to take care of the other two types of data, which so far has not been modeled properly. And because they're not modeled properly, there is a lot of gaps. We're not covering some of the vulnerabilities that we need to take care of. So that's why we decided to break the data into three main types. All right? So for each of the other two, process and control data, we are saying that, hey, we also need to take care of decipher, implicit and explicit. Right. So the next few slides is where, as good academia, we're supposed to bore you to sleep. So please try to stay with us because we're going to throw you tons and tons and tons of formula. All right. If you need how to work them out, you can feel free to contact us later. Okay. Right. So let's talk about first the product data. The explicit component of each of data. So for both the three types of data, we're saying that basically this includes the amount you need to pay to buy the data, right? And of course, maybe the amount of money you need to spend to create that data. So for example, I need to hire an operator, work X number of hours to create a CAD/CAM file, right? That gives me a certain value to that data, right? So we just do a simple formula, sum up for all the three components. The implicit component, right? So in a loose way, this is like your amount that you will get to loss if your entity goes down, right? So it talks a bit more like availability, okay? So in this case, control data, all right, will not have any component, right, based on avenue or market share. Right. So for this part, we have broken down three components again, and we're saying that only for product and process data, right, you may have in terms of market share, loss, etc. Take an example. Woei in UK, when they make the you need to build the Airbus wingspan. You need to revert every single point, X and Y coordinate. Now, this CAM data is worth a lot of money. Because if I can steal that data from you, I know exactly how to replicate your wingspan, right? So that's why it may lose. The company may lose your market share. You may lose money if you lost some of this product and process data. But the control data, the signal that from the PLC that goes to the cutter to say, all right, spin at for example 50 RPM, etc. This is only localized to that machine. So this kind of control data has no value, right, outside the shop floor, okay? Which is why we are saying that this ability does not have any market share component to it. Next, we talk about the decipher component. This talks more about the intellectual property loss, or IP, not our internet protocol that we talk about, right? So in this part, if I lose my CAD/CAM file, if I lost my design of my latest 3D printed car body, what is the amount of IP I would lose? So yeah, once again, we're going to give you a very complex mathematical formula. But in this case, what we're trying to tell you is that we're going to average it, normalize it by the average job price, right? Per job that you're given, when you need to get your 1 million CNC machine to produce this part, how much on the average are you losing if you lost this data? Okay, so we sum everything up and we normalize it by the average job price that the company get. We get our damage index. In other words, if this entity goes down, let's recap, how much do you lose? Okay. By the way, each CNC machine costs typically in the region of about 1 mil and above. So that is the scale we're looking at, right? Okay. Now we know that maybe we can rank all the machines that I have on my shop floor based on the damage index, which is the most machines that maybe I need to protect the most based on DI, my damage index. But what is the associated vulnerability with that machine, right? Therefore, I may have two machines with the same damage index, but one of them are more vulnerable, so I need to patch that more. Okay, so this one we came up with a model called the vulnerability quantification table. And we're going to rely heavily on our CSV to help us with this job. Okay. Quick recap, we have 3 types of data: product, process, and control. All right. So let's go back to our CVS where we talk about our CIA: confidentiality, integrity, availability. Right. So we came out, as I said, with this codification table, right? Help us to do some simple matrix manipulation, right? Hopefully for some of you guys, this reminds you of your college days, your matrices, things like that. We do foresee that this is our proposed values, and therefore individual shop floor, using things like machine learning, etc., the weights may tune according to your industry, according to the company's needs. Right. And then if we go into our CVS, right, I think people who deep dive a bit will notice that there are certain other components that went into a formula, right? So we deep dive into that, and we came out with what we call a impact matrix. Okay. So what happened is that let me quickly show you everything first. Right. So what happened is that we put everything into a formula. Right. So if you look at my machine have 10 vulnerabilities. Out of these 10 vulnerabilities, 3 are high of vulnerability in terms of availability. How many are high score in integrity and availability, etc. Right? So we're going to sum it up. Then we get our with the scoring matrix C. Then we multiply them together, and then you get a final number. Right? So based on this final number, we then have a good approximation. We're not saying that it's foolproof, but you have a good approximation as saying that now I know in terms of availability, what is the vulnerability index in terms of confidentiality, availability, etc. Okay. So now having come up with this number, what do? We go back to our shop floor. We look at a couple of our huge machines. So we do a scan of all the machines. Right? We found all the vulnerability, some of the vulnerability that's out there that has not been patched yet, etc. And then we sum everything up and put it in a graphical form. So in this graph, what you see is 5 of the entities that we have on our manufacturing shop floor. Okay, so each one of the so you can see the 3 different components we talk about, right? And then we color code them, right? So of course, green is very low, high is red alert, etc. And so with a quick look now, the manufacturing IT folks or the CEO now can know, right? I need to pay some money to patch certain thing. Where do I get started? Now I know. Where's the vulnerability that is most important to you? Is it integrity, confidentiality, or your availability? Now you know. So we could look now, you know what shall I patch first, right? Because we all know this. As IT folks, right? You go to the boss, you ask for, we always need $10 million to patch everything. But the boss is going to give us $10,000. So what do we do with that? We have to strategize and see where to patch first. So at least with this model, there's something for us to work on. Okay. So in conclusion, we try to come up with a model. We're focusing on the data, all right? And based on this data, what we are saying is that we can look at data index and vulnerability index. And from there, we know, hey, where shall we get going? Where are the high risk? Where are the most vulnerable assets out there? Right? And this is very centric to the manufacturing floor. All right? So we have customized this very specifically for the manufacturing industry. So we get to give the folks there a better handle. And we have came up with a visualization tool, right, to visualize the whole thing. So what we're going to do next is, of course, you have noticed, some of you have noticed, we are talking about data at rest. Data that is not moving, right? Some of us who have played with things like DLP know that they are also about data in use, data in transition, in the network, and motion. So we're going to move into that next, right? And as I alluded earlier, the weights, the VQT, we are going to try to use some machine learning to fine-tune them for individual specific shop floor. Okay, so for those who are interested to work with us, maybe you want to try to apply this model back at your workplace, or you may have a customer who are talking about it, and you'd like us to come in and work together. feel free to contact us. All right, we'll be hanging around for lunch. Right, thank you.
And thank you very much, Simon and Lim.
Thanks.
Are there any questions from the audience?
So for the damage index, it doesn't seem you considered integrity issues. So if someone changed the CAD drawing and what the impact would be, because you could produce 100,000 motor blocks that were 0.5 millimeters off or whatever. Is that also a plan, or did I just miss that part of the damage index concept?
So you are referring to the damage index. Will it take into consideration if someone mess around with the product data?
Yeah.
So
ATP, for example, or corporate espionage would be interested in changing your product line that you would maybe not discover because it was made according to plan.
Okay, so for this mathematics model that we propose, in fact, we are looking at the maximum extent. So let's say someone messed with my CAD model. Instead of the 10 millimeter engine block, it changed it to 8 millimeter. So the calculation here will assume a full damage, meaning that the entire product will gone. So because during the calculation, we take in consideration that particular drop price, that how much we are charging the customer. Assume this part is worth $500. So that calculation already take into consideration if someone touch my CAD model or the product data, the entire 500 will gone. So that is the implicit component. Yeah. And it also actually add on. We are not just talking about enterprise lost 500 because when someone changed my CAD model, I may not deliver on time or customer may complain. So we already take into consideration what about the loss in market share and loss in reputation. So that's why the calculation, we actually take in 3 components, the implicit, explicit, and the decipher component. These 3 components is to taking care of all the concern, when I change the data. Thank you.
Are there any more questions from the audience?
So have you actually used this in a real world scenario? Because it seems like a complicated thing to calculate all of this, right? So typically we have, you look at the risk, probability, severity across the CIA index, and then you have another layer of product, process, and that sort of thing. And then you finally end up with one index number. But the method of calculating that index number requires, some sort of PhD. So it's basically you present a number, but when I guess if you're going to present this to, let's say you present it to senior management for an investment, but the method of calculating that number is lost under layers of complexity, the number means less because they can't really grasp how exactly you calculated the number if it's so complex to come up with the number in the first place.
Yeah. So in fact, to answer the first question first, did we really try out this model? So the first mathematical model, actually we try out in our own shop floor. So in NYP, School of Engineering, we got this Center of Digital and Precision Engineering. So we take in all different kind of industrial project and we do it, and we do charge our customer, so-called. So we actually tested it out here and we get the numbers that for us, we actually think there are some fine-tuning is needed and we tune it. After that, we move about, we actually publish a conference paper in Germany. So, and also we tie up with a SME. So a SME actually use this model to analyze their system. So we are in the process to get their feedback. Is this number convincing? So end of the day, it's about the verification. A lot of researcher from different university, PhD, they come up with a mathematical model. But how to convince people? So for this particular model, when you look at it, it looks very complicated. But actually, when you sit down and digest each line of the formula, we are just talking about the real value of the data. So if I got a data, how much time I spend to create this data? And if this data gone, I cannot produce a part, how much profit am I losing? We are just trying to add all these things up together and then come up with an index. And this index is scaled to the average job price, which is when I come to tell my boss, okay, your index is 2.0. What does that mean? So we are trying to tell them, if this machine down, you may lose roughly, for a company, the average job price that I'm charging a customer, let's say, is 10K. So we are trying to tell them, if this machine down, you are not just losing 10K, you are losing 2 times of the 10K, which is 20K. So we are trying to convince this to managing level of people or IT people. And until today, it looks like it's quite convincing, just that we need more people to join in to test out this model in their shop floor. So the more people involved, and then slowly, we believe this one will be kind of a standard tools for manufacturing sector to analyze their cybersecurity behavior of their shop floor. Yeah.
Are there any more questions from the audience?
Sorry, just a question, maybe not so relevant. Your research is on application of finding an index to model how what kind of cost or damages to manufacturing process like CNC, which is subtractive manufacturing. How about advanced additive manufacturing, like additive manufacturing, which the machine could be much cheaper? So how do we apply this to other similar but not on CNC machines?
Yeah. So actually, this question actually lay down to, how should I say? Yeah. Your approach, you are trying to say, if this machine only worth, let's say, 5,000, like a 3D printer, compared to a CNC machine, $500,000, okay? So exactly because of this reason, we come out with this damage index. So this damage index telling you, damage index of 2.5 is equivalent of losing a money of 10K. Then if my machine only worth 5K, do I need to pay a 10K solution to protect this 5K machine? So because of this reason, we say, hey, cybersecurity for manufacturing is different. We can't be paying 10K to protect a 5K machine. So in order to give a quantitative measure on the damage, we need a mathematical model, something like this. So this mathematical model will tell you, if your damage index is 1.1, it's almost approximate to 6K, then your machine 5K, do you want to protect it? Maybe end of the day, you will say, yes, I need to protect it, but protect it with just $100 of solution. So to sum up the thing, without these tools today for manufacturing enterprises, we really don't know how much money should we spend to protect our solution, or what kind of solution should we adopt to protect our entities, because we don't know what kind of damage are we suffering when we experience a cyber attack. So we believe this one will serve as a very initial stage before we talk about what kind of solution or what level of solution should we put onto our manufacturing sector. Yeah.
Okay, thank you.
Are there any more questions from the audience? Okay, if there are no more questions, please do keep in mind that Simon and Lim will be around for the rest of the day, so you can ask them anything that you might like. And please give it up one more time for Simon and Lim. Thank you very much.